Assalamu alaikum students. Today I am here with another H-NMR problem. Till now I have discussed briefly some important topics in H-NMR series which are required to solve simple H-NMR problems. So we have discussed chemical equivalence, integral and integration, chemical environment and chemical shift value, and splitting, that is n+1 rule. These are the topics which are required to solve simple H-NMR problems. If you haven't watched that lectures, then I recommend you to watch these lectures for better understanding to solve simple H-NMR problem. I will attach link of this series in a discussion box as well. So here is another H-NMR problem. So the problem is, draw the structure of an ether with the formula C5H12O2 that fits the following H-NMR problem. So we have to find out the structure of ether, right? So this is the ether group, right? And you should know this. I have already discussed about it कि आपको जब भी H-NMR प्रॉब्लम सॉल्व करनी होती है तो उसके लिए आपको पहली चीज़ तो मॉलिक्यूलर फार्मूला रिक्वायर्ड होता है, ठीक है. देन यू हैव टू फाइंड आउट IHT, देन functional group should be mentioned, or you have the ability to find out the functional group with the help of the IR, right? Then you have to find out the fragments with the help of the given spectrum, right? Then after it we just combine all the fragments and the structure is prepared. Or so you can see here, I am going to talk about this peak first. So first thing you should see here is that there are 5 carbons and 12 hydrogens, but only 2 types of hydrogens are present. You can see with the help of the spectrum, right? So in the spectrum only 2 types of protons are mentioned. It means that the molecule is symmetrical, right? So molecule is symmetrical, right? So you can see here, this is the proton, right? How many protons? These are integral is 3.97, which means that around 4 protons are here, or around maybe 4 or maybe more. So 4 protons are here, which are similar in nature, and they are splitting into singlet, right? So it is splitting into singlets. So the possibility is this. You can see here, this is CH3 and it is attached to the carbon which does not have any proton. Or here could be another possibility as well, that CH3 or the carbon having hydrogen may be connected to the another atom which does not have proton, right? So you can see here, this carbon is attached to the carbon. Why I am sure about it if this carbon is attached to the carbon rather than oxygen? Because in the second peak you can see here, this peak chemical shift value is higher than the first peak. So obviously whenever there is a higher chemical shift value, it means that the carbon having proton is attached to the maybe more electronegative atom or maybe de-shielded atom. So here we can say that this carbon is attached to the oxygen, right? So this is the possible fragment of this peak, okay, corresponding to this peak. And obviously it is mentioned here are 4.09 integral value, so it is mentioned that around 4 protons are similar. So 3 protons are here, and maybe other protons are, maybe other methyl group will also attach to this. So there are, I found 2 fragments, right? The first one is this, and the second one is this. So I think the possible structure is this, right? So you can see here, this is the basically first fragment, and I have mentioned in the fragment that this carbon is basically attached to the 2 R groups. So this R means that it is generally maybe attached to the any compound which rather than the proton. So you can see here this carbon is attached to the oxygen, right? So this R group, basically this is this R group. So this methyl group, right? So I have also already mentioned that the molecule is symmetrical. So you can see here this molecule is symmetrical. Molecule have a symmetry. So this is CH3 and this is CH3. So this methyl group and this methyl group, this one and this one is this peak, right? And this methyl group and this methyl group is correspond to the this one. So it is all about today's lecture. I hope you got understand, and if you got understand,